It is unlikely that the furnace wiring is directly causing the thermostat to burn out. However, there are related factors that could contribute to the issue. Possible causes of thermostat burnout include voltage fluctuations, grounding issues, loose connections, and thermostat compatibility. Additionally, other considerations include thermostat type, electrical surges, and overheating. Inspect the furnace wiring for loose connections or damage. Check the transformer for signs of overheating or burning. Install a surge protector on the receptacle powering the furnace. Relocate the thermostat to a cooler location if possible. Consider replacing the thermostat with a compatible model. If the issue persists, it may be necessary to consult with a qualified electrician to determine if there are any underlying electrical issues with the furnace or wiring. Consider these factors in more detail. Firstly, voltage fluctuations. If the voltage at the receptacle is consistently high, for example above 125 volts, it could damage the thermostat's internal components over time. Testing the receptacle showing 120 volts indicates proper voltage, but monitoring for fluctuations is recommended. Secondly, grounding issues. If the receptacle is not properly grounded, it could create a voltage difference between the thermostat and the furnace, leading to damage. The ground test can confirm proper grounding. Thirdly, loose connections. Loose connections in the furnace wiring could create a resistance that increases the voltage at the thermostat. Inspect all connections for tightness and corrosion. Fourthly, thermostat compatibility. Ensure that the thermostat is compatible with the furnace system. An incompatible thermostat may not be able to withstand the electrical load. Refer to the furnace and thermostat documentation for compatibility information. Consider these other factors as well. Firstly, thermostat type. Low-voltage thermostats are typically powered by a transformer that reduces the line voltage to 24 volts. If the transformer is faulty or not sized correctly, it could provide an incorrect voltage to the thermostat, leading to burnout. Test the transformer output voltage to ensure it is within the specified range. Secondly, the electrical surges. Power surges from lightning strikes or other electrical events can damage thermostats. Consider installing surge protectors for critical electrical devices. Surge protectors can help prevent damage from voltage spikes. Thirdly, overheating. If the thermostat is located in a hot area, such as in direct sunlight or near a heat source, it may overheat and cause internal damage. Relocating the thermostat to a cooler location may resolve the issue. To address these possible causes, these are steps you can take for further troubleshooting. 1. Inspect the furnace wiring for any loose connections or damage. 2. Check the transformer for any signs of overheating or burning. 3. Install a surge protector on the receptacle powering the furnace. 4. Relocate the thermostat to a cooler location if possible. 5. Consider replacing the thermostat with a compatible model. If the issue persists, it may be necessary to consult with a qualified electrician to determine if there are any underlying electrical issues with the furnace or wiring. When inspecting the furnace wiring, pay close attention to the wire gauge and insulation condition. Over time, wires can become brittle or damaged, leading to shorts or open circuits. Verify that all wire connections are secure and properly tightened. When checking the transformer, use a multimeter to measure the input and output voltages. The input voltage should match the supply voltage, typically 120 volts, and the output voltage should beat the specified low voltage, often 24 volts. If the transformer is producing incorrect voltages, it may need to be replaced. Surge protectors can help protect against voltage spikes caused by lightning strikes, power outages, or other electrical events. Choose a surge protector that is rated for the voltage and amperage of the furnace circuit. When relocating the thermostat, consider factors such as airflow, sunlight exposure, and proximity to heat sources. The thermostat should be located in a central location where it can accurately sense the temperature of the room. Before replacing the thermostat, consult the furnace and thermostat documentation to ensure compatibility. An incompatible thermostat may not function properly or could damage the furnace control board. If you are not comfortable performing electrical work, It is always best to consult with a qualified electrician. An electrician can diagnose and repair any underlying electrical issues with the furnace or wiring. Additional considerations include the type of thermostat being used. There are several types of thermostats available, including mechanical, electronic, and smart thermostats. Each type has its own advantages and disadvantages. Mechanical thermostats are simple and reliable, but they may not be as accurate as electronic thermostats. Electronic thermostats offer more precise temperature control and can be programmed to automatically adjust the temperature at different times of the day. Smart thermostats can be controlled remotely using a smartphone or other device. The location of the thermostat can also affect its performance. The thermostat should be located in a central location where it can accurately sense the temperature of the room. Avoid placing the thermostat near windows, doors, or other sources of drafts. The thermostat should also be located away from heat sources such as lamps, appliances, or direct sunlight. Regular maintenance can help prevent thermostat problems. Clean the thermostat regularly to remove dust and debris. Check the wiring connections to ensure they are tight and secure. Replace the batteries in the thermostat if necessary. If you notice any signs of damage, such as cracks or discoloration, replace the thermostat immediately. When troubleshooting thermostat problems, start by checking the simple things first. Make sure the thermostat is turned on and set to the correct temperature. Check the batteries in the thermostat if it is battery powered. Inspect the wiring connections to ensure they are tight and secure. If you have a multimeter, use it to measure the voltage at the thermostat terminals. If the voltage is not correct, there may be a problem with the transformer or the wiring. If you have checked all of the simple things and the thermostat is still not working, you may need to replace it. Before replacing the thermostat, consult the furnace and thermostat documentation to ensure compatibility. In addition to the factors already mentioned, consider the possibility of electromagnetic interference. Electromagnetic interference, or EMI, can disrupt the operation of electronic devices, including thermostats. Sources of EMI include power lines, radio transmitters, and other electronic equipment. If the thermostat is located near a source of EMI, it may be necessary to shield it or relocate it to a different location. Another potential cause of thermostat burnout is moisture. Moisture can corrode the thermostat's internal components and cause it to fail. If the thermostat is located in a damp or humid environment, it may be necessary to protect it from moisture. This can be done by sealing the thermostat housing or by installing a dehumidifier in the area. Consider the age of the thermostat. Thermostats, like all electronic devices, have a limited lifespan. Over time, the components in the thermostat can degrade and cause it to fail. If the thermostat is more than 10 years old, it may be time to replace it, even if it is still working. Check the wiring diagram for the furnace and thermostat. The wiring diagram will show how the thermostat is connected to the furnace control board. Make sure that the thermostat is wired correctly according to the wiring diagram. If the thermostat is not wired correctly, it may not function properly or could damage the furnace control board. Verify the DIP switch settings on the furnace control board. The DIP switches are small switches that are used to configure the furnace control board. The DIP switch settings must be correct for the thermostat to function properly. Consult the furnace documentation for the correct DIP switch settings. Use a non-contact voltage tester to check for voltage on the thermostat wires. A non-contact voltage tester is a device that can detect the presence of voltage without making direct contact with the wires. This can be a useful tool for troubleshooting electrical problems safely. If the non-contact voltage tester detects voltage on the thermostat wires when the thermostat is turned off, there may be a short circuit in the wiring. Check the continuity of the thermostat wires. Continuity is a measure of how easily electricity can flow through a wire. If the continuity of a thermostat wire is poor, it may indicate a break or corrosion in the wire. Use a multimeter to check the continuity of the thermostat wires. Consult with a qualified HVAC technician. If you have exhausted all of the troubleshooting steps and the thermostat is still not working, it may be necessary to consult with a qualified heating, ventilation, and air conditioning technician. An HVAC technician has the knowledge and experience to diagnose and repair complex heating and cooling systems. Provide the HVAC technician with as much information as possible about the problem. This will help the technician to diagnose the problem quickly and accurately. Information should include the type of thermostat, the type of furnace, and any troubleshooting steps that have already been taken. Be prepared to answer questions about the history of the problem. The HVAC technician may ask when the problem started, how often it occurs, and what you have done to try to fix it. Follow the HVAC technician's instructions carefully. The technician may ask you to perform certain tasks such as turning off the power to the furnace or removing the thermostat cover. Following the technician's instructions carefully will help to ensure that the repair is done safely and correctly. Do not attempt to repair the furnace yourself unless you are qualified to do so. Working on a furnace can be dangerous, and it is important to have the knowledge and experience to do it safely. If you are not qualified to repair the furnace yourself, it is best to leave it to a qualified HVAC technician. In addition to the steps above, remember to consult the National Electrical Code, specifically Article 430 regarding motors, motor circuits, and controllers, and Article 440 dealing with air conditioning and refrigeration equipment. These articles provide detailed requirements for the safe installation and operation of HVAC equipment. Ensure that all wiring complies with the NEC requirements and local codes. Also, consider the ambient temperature around the thermostat. High ambient temperatures can affect the accuracy and performance of the thermostat. If the thermostat is located in an area with high ambient temperatures, consider using a thermostat that is designed for high temperature environments. Investigate the possibility of harmonic distortion in the electrical system. Harmonic distortion can cause voltage fluctuations and other electrical problems that can damage electronic equipment, including thermostats. If you suspect that harmonic distortion may be a problem, consult with a qualified electrician to have the electrical system tested. Look for signs of corrosion on the thermostat terminals. Corrosion can create resistance in the electrical connections and cause the thermostat to malfunction. Clean the thermostat terminals with a wire brush or contact cleaner to remove any corrosion. Replace any damaged or corroded wiring. Damaged or corroded wiring can cause a variety of electrical problems, including thermostat burnout. Replace any damaged or corroded wiring with new wiring that is properly sized for the circuit. Double-check the wiring connections at the furnace control board. The wiring connections at the furnace control board are critical for the proper operation of the furnace and thermostat. Make sure that all of the wiring connections are tight and secure. If any of the wiring connections are loose or corroded, tighten them or replace them as needed. Confirm the power supply voltage to the furnace. The furnace requires a specific voltage to operate properly. If the power supply voltage is too high or too low, it can damage the furnace or the thermostat. Use a multimeter to measure the power supply voltage to the furnace and make sure that it is within the specified range. Investigate the possibility of a faulty furnace control board. The furnace control board is the main electronic component that controls the operation of the furnace. If the furnace control board is faulty, it can cause a variety of problems, including thermostat burnout. If you suspect that the furnace control board may be faulty, consult with a qualified HVAC technician to have it tested. Always disconnect power before working on electrical components. Disconnecting the power to the furnace is essential for safety when working on any electrical components. Turn off the circuit breaker that supplies power to the furnace before starting any work. This will help to prevent electrical shock. Use appropriate personal protective equipment (PPE). When working on electrical equipment, it is essential to wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. This will help to protect you from electrical shock and other hazards. Following these additional considerations and troubleshooting steps will help to identify and resolve the issue of thermostat burnout. Remember to prioritize safety and consult with qualified professionals when necessary.